So I would like to introduce our next resource person, Mr. Phanindra Kumar Kosaraju. So he is presently working as a structural engineer at IDOM, Minneapolis, Minnesota, United States. And he is having a progressive experience in the design of industrial facilities, OH, MHS, and telecommunication infrastructure. So I would like to hand over the session to Mr. Fani Kumar. So, Mr. Fani, you can start your session. Thank you.
Hi everyone. Let me know if anyone cannot hear me. I am about to share my screen and give me just 1 minute. I assume everyone can see my screen now.
Yes, it is visible.
Okay. Myself, my as introduced, I'm Phanindra Kumar Kosaraju. I had done my bachelor's from Bapatla Engineering College, and I had done my master's here in States at University of Missouri. And currently, I'm working as a structural engineer at IDOM. And mostly, I do work on industrial facilities and overhead material handling systems. So today I'm going to present a manufacturing facility that I had worked a year or a couple of years ago. So located here in Arkansas. So this is having a little bit of confidential information. So I would recommend not to share the topics discussed here publicly, or not to make any uh, private recordings. So, and before starting the thing, I would like to thank our HOD Satish Kumar for giving me the opportunity, and everyone who is working for these sessions. And going forward, this is the overall layout of the plant. And in this plant, the client wants to produce the foam sheets, and the processing was designed by a different team, hired directly by the client, and the client has specific requirements in the processing. So it was prepared as per the client requirements, and then the structural engineering and the civil engineering team was involved later after getting the processing plan uh, prepared. So in this manufacturing facility, the processing involves various steps. So starting, like, they have a specific requirement of a tunnel building, and the sheet needs to go through the building at a certain slope, and they, before starting the site selection, they are more specific about getting a site that is having a slopy surface, so that they can utilize the natural slope instead of preparing the uh, site for that slope. Uh, Eventually, they made some modification for the slope requirements, but they reduce the efforts by selecting the site that is having the elevation they are looking for. So within the process starts with the BA tanks, which is at the higher elevation here, and then the upper building here, the tunnel building, and the lower building. And adjacent to the lower building, there is a office building here. and the whole material will be transferred to the warehouse, and then the truck loading shed is at the end, so that from the warehouse they will. And there is one more truck loading place here, and there were silos and other equipment pads all around the building, and there were minor buildings around too, like small cabins or for single person working places, things like that. So starting with the BA tanks, the BA tanks involved like three huge tanks that were going to be uh, located in that tank area. So that tank area involves a slopey surface for the trucks to be parked and load the tanks that were installed on the tank pads. So this tank area needs to be like designed for the as a contamination area because of the liquid that was going to be stored in that tanks. So as per the code requirements, the containment area needs to be calculated for the 110% of the volume of the largest tank, along with the volume displaced by the other tanks and the rainfall volume. And in this case, along with this tank area, we had added the area of this slopey surface because of the trucks parking here while filling the uh, vessels. The owner has requested to include this area since they are expecting some spills during the filling of vessels. So the current contamination area like involves this whole volume, and these are some details that were uh, involved over there. So this is a section cut showing all the three pads, and let me go back. So for this tank area, we have a outlet here. So everything will slope in that direction. So and the tanks were prepared in different pores. So the tanks need to be like the first pore needs to be roughened, and the bonding agent needs to be applied accordingly. And also here we had recommended a water stop in the shear key between the tank pad and the uh, wall to avoid the leakage. So in this presentation, I think I will switch back and forth between my presentation and the drawings I have, because when I try to snip the drawings from, it is not clear. It is getting me the blur. So I thought it's better to switch between my presentation and the drawings I'm having on file. So along with this, there is a cable tray going around this tank area that carries the cables. Let me try to switch. So this is the cable tray I was speaking about, and we were asked to provide the cable tray for a capacity of 400 pounds for linear foot. And the cable tray some supports were directly from the tank slab, so we didn't provide any additional foundation for the supports that were located on the within the tank area. But for the supports adjacent to the tank area, we had provided the pier supports, and the cable trays. The cables were at two different elevations, so we had provided accordingly. So a pipe with the channel support, completely shop welded, and also a pipe with a channel on the side. So and these are the details for that. And there is light poles all around, and also the fence all around. The fence was supported from the tank walls, so there is no additional foundation for that. And the material prepared from this tank area will be transferred to the upper building. So within the upper building was designed for the to support the extruder. So the manufacturer provided the loads of the extruder. There were multiple wheels for the extruder. The extruder moves back and forth within this region, and each wheel of the extruder is around 25 kips of load will be applied from each wheel. And there were some rails that needed for the wheels to move back and forth, and these rails were provided by manufacturer too. So we had just provided the openings within the slab to hold that rails, and the openings were later filled with the motor once the rail was placed. Uh, and within this upper building we have a electrical room. This is a 2-hour rated electric fire rated electrical room. So this room is like enclosed within the building, so there is like a separate roof for this electrical room, and everything is 2-hour fire rated for this room. The whole walls were made of the masonry, and the roof is made up of the steel structures with the joists. And the joists were coated with a 2-hour fire rated material. And coming to the while transferring from upper building to the tunnel building, there is a conveyor within the tunnel building, and also it started to slopes down from here. To accommodate that slope down, we had prepared the retaining wall accordingly, so that yeah, the foundations and also the building columns were sloped down accordingly. And these are some of the details for that. And on this project we are responsible only for the foundations and supporting the different equipments. The main the whole other frame is a pre-engineered metal building, and the loads we get onto the foundations were provided by the engineers who worked on that buildings. So, and this And this facility is located in a location where the frost depth is 12 inches. So everything we are doing, like, that needs to be below 12 inches. So we had planned our foundation below 12 inches so as to avoid the frost depth. And yes, and all these foundations were designed as per ACI 318. And initially, one of the requests from client is to use the fiber reinforced concrete, since the fiber reinforcement material is provided from their one of their other manufacturing facilities, so they want to utilize the fiber reinforcement instead of the regular rebars. So the slabs were designed using the FRP, and the ACI 440 is the controlling code for that. And in some places, there is a reservoir where we need to use the regular slab, and also the in other places where we have the reinforced slab, we had utilized the ACI 360 or. And while doing the foundation design, we try to explore the different availabilities to do the foundation. Since this is a pre-engineered metal building, it is very light in weight, and there is a lot of lateral wind load acting on to the structure. So there is a lot of uplift. So we had considered the option of doing a slab with a hairpin and trying to stick the foundation out of it, but it that will restrict us from utilizing the FRP. And in the future, if they want to install any other equipment to the floor, they can't install it, since they might cut the rebar, or there is a possibility in the future for them to install the new equipment. So we had recommended a shallow foundation instead of the other options. So So going on to the tunnel building, within the tunnel building, the conveyor goes continuously through the tunnel building, and the conveyor needs to be maintained at a constant slope of 10 degrees. And for the tunnel building, a shear block was installed at the bottom of the tunnel building to carry the shear load uh, inserted due to the self weight of the tunnel. And between the tunnel building and the lower building, there is a requirement for 3-hour fire rated wall. So it was designed. And for the interior walls, as per IBC, it was recommended to have the walls designed for a minimum horizontal load of 5 pounds per square feet. So going back to the drawing. So after this upper building, it started to slope down, and when we enter into the tunnel building, this is the plan view of the tunnel building and the elevation. So as we can see here, it is continuously sloping down, and over here we had designed a shear block so that the whole tunnel will be like laterally supported from here. And along with the lateral support, the tunnels were supported vertically with the saddles at every uh, 25 feet. So it is continuously supported vertically with the saddle. The plan that owner came up with, the saddle plan. So we are responsible to provide the floor to support the saddle. So owner had given the loads that are going to be applied on the floor from the uh, tunnel to the saddle and then to the foundation. So here we have the FRP floor on either side, and the regular reinforced floor in between, where the whole tunnel is supported. And this is the elevation view of the shear block I'm speaking about. And this is the saddle plan owner came up with. The saddle is supported with a uh, uh, rod and bolted. There is a bolt to adjust the saddle elevation, final elevation. And this whole saddle is supported with a skid plate, and the skid plate is uh, uh, placed on the slab with connected with a stud. And the whole skid plate is like uh, installed during the initial pour. So it is like in place, uh, not post installed, I meant. So this is the shear block section cut. And at the end of the tunnel building, we have a reservoir, like at the starting of the lower building, a quite amount of water load from the reservoir will be applied on this lower part of the tunnel building. It was taken into consideration. So when we go to the okay, sorry, let me go back. There is a here between the tunnel building and the lower building, we have a wall here that needs to be 3-hour fire rated. That wall needs a opening for the tunnel to move forward, and couple of openings for doors on either side, and also uh, some cable trays that electric cable trays that needs to go through the wall. So these cable trays and the insulation around the cable trays is going to be provided by the electrical team. And for structurally, we had designed this wall for a lateral load of 5 psf, since this is like located internally. And uh, so the lateral load is controlling this wall design than the gravity load. So to since this wall is like around close to 30 feet height, and it is sloping down, and to get the lateral support, we had included the bond beams at every 6 feet, not more. We had recommended bond beams not more than 6 feet in height, and also uh, pilasters here. So, and client had requested on the tunnel side, they had requested for a fall protection anchor, since they are planning to use the fall protection anchors while they were getting down here into this lower regions. And there is like a floor over here. The floor will be completely a steel frame, and they to get down they had requested for a fall protection. So the fall protection was included with post installed anchors and a plate over there. So this is a uh, piece provided by a manufacturer. So we had included that with a post installed anchors. Uh, this is detail for pilasters. The pilaster is 16-inch wide and 16 by 24 inches. So, and yeah, these are some of the details for at the end. So here, along with the shear block, a little amount of lateral load is carried by this wall that is supporting the masonry wall too. So uh, uh, this is the masonry wall, and this is the foundation for the masonry wall. And here, this is the reservoir slab, and the whole thing is like supported by a single spread footing. This the final tunnel building pier, masonry wall, and slab here. Coming to the lower building, it consists of a reservoir, and also the lower building. There is a foundation for a robot or a zip crane, and a loading dock is there. And adjacent to the lower building, there is a office space. So the reservoir, they had requested for a capacity of for a 2.5 ton forklift to go back and forth on the reservoir, on top of the reservoir. So the reservoir design was controlled by ACI 350, and as per the ACI 350, they had the recommendation from ACI 350 is that maximum spacing of the rebar increase shouldn't be more than 12 inches to ensure the water tightness. In our case, we had provided the 8-inch rebar spacing because of the structural requirements. Uh, this is the overall lower building plan, and this is the place where the tunnel building gets connected to the lower building. So the tunnel building is much less wider than the lower building. Tunnel building is around 30 feet or something wide, and the lower building is like a lot wider. So so this is the foundation for we got this dog. Here is this is um, a bit-
Stephanie?
Hello, Phanindra.
Yeah. Can you hear me?
Your voice is not audible.
Hello. Hear me? Hello.
You should just now. Your voice is not audible, Miss Funny.
Okay.
Yeah, right. Now it is okay.
Okay. I don't know what happened. It might be some network issues. Can I go ahead or?
Yeah, you can go ahead.
Okay. I will try to speak loud. So the reservoir part, as I was mentioning, the tunnel will end here and it will be slightly cantilevered out, and it is going to be in that cantilever part, and the loads were
Sorry to interrupt.
considered.
Your screen is not visible. Sorry, your presentation is not visible.
Sorry, my presentation, what?
The presentation is not visible.
Oh, okay.
Nearest.
Is it good now? Can you guys see it?
No.
Yes, I can hear you. Can you guys hear me and see at my presentation?
We can hear you, but your presentation
No,
is not visible.
presentation is not.
Okay. Uh, I'm not sure why, but I'm trying to reshare my screen once again. Can you see it now?
No, sir.
No, it
Not
is
yet.
not visible.
Can you hear me now? And see is my presentation visible? Can you guys hear me now?
Yes.
Can you see my screen?
No, no, sir.
Oh. I'm not sure why I'm sharing my screen, but I'm not sure why you guys can't see it.
Now it is visible.
Oh, okay. Okay, let me continue here. Okay, okay. This is the reservoir building I'm speaking about. So the reservoir is located with 5 feet, the overall thing is 5 feet 3 inches, but the reservoir is 4 feet 6 inches deep, and that comes with a 10 inches slab. So as per that ACI requirements, we had studied for the capacity of the slab to hold that 2.5 ton capacity forklift, and provided the reinforcement accordingly. Within the reservoir building here, this whole thing is the concrete slab, and in between here, this middle section, this 10 feet is removable sheets. So here we had provided this design where a curb will come all around the reservoir. With to that curb, a angle L 8 by 6 by half angle will be like installed all around with this welded studs, and also this shop welded small bolt, so that uh, we can place the W6 by 16 as required. So even this support beams, W6 by 16 support beams, they are removable, and the plate on top of those beams, the floor plate is also like removable. The whole thing can be removed and placed back as per the requirements. So these are the this is the detail, and also a section cut looking at the reservoir wall or the curb. So these are the baffle walls spaced approximately 8 feet 8 inches to 9 feet 4 inches, that supports that concrete all around. So when we go to the section cuts, this is how it looks. The whole thing is a reservoir, and the center part is the removable support beams and the plates. This is the detail which we had utilized for that reservoir wall. And everywhere we had utilized 8-inch spacing. 12 inches is the max allowed for that. And coming to the wall, this is a very long wall and with huge door openings. So the door, the small door openings, and immediately next to it is a huge 14 feet wide opening and 14 feet tall. So this, on top of this openings, the lintel, I believe these are 24-inch deep lintel beams, which were designed considering the arching action on top of the lintel beams. And the rest of the load was considered to be transferred through the pilashes. Even on this one, the lateral load is controlling that design. And all along the length of the wall included the control joints as per TMS, the masonry 402/602 code requirements. So the control joint spacing was calculated based on the code requirements, and also the drying shrinkage temperature effect and the carbonation shrinkage factors. Those were taken into consideration in the design of the walls. And as per the TMS code requirements around the openings, we have to like reinforce all around the openings with the rebars, and also these are uh, in the previous wall we don't have the space to center the pilasher on the foundation. So let me, here we have the space to center the pilasher. So the difference I'm trying to say is here on the other side, we have the opening on on the other face. We can't provide the foundation extending onto the other side for this pilaster. So the pilaster is flush with the masonry wall, whereas in the other wall, the pilaster is centered onto the wall, and this whole the wall is supported by a continuous foundation. So let me, looks like I didn't add that detail here, but if you see the elevation view, there is a continuous foundation for this masonry wall. And these are the details for the control joint, the fire rated control joint. In the current case, the contractor needs to utilize these details since we need a 3-hour fire rated wall. This is the detail that was utilized, that needs to be utilized. And this is the section 24-inch deep lintel beam on the bigger opening, and the other one is the smaller door opening, which is like a 8-inch lintel beam. So these are the details for those. And here the wall is grouted at every 24 inches, and the rebar, number 6 rebar, is provided at every 24 inches. And similar to the other wall, it's the same cable tray running all along. And as I mentioned earlier, the electrical people needs to provide a insulation around this opening. So the insulation is also 3-hour fire rated. And uh, a bond beam is needed to transfer the lateral loads all along. The bond beam should be installed no more than 6 feet. 6 feet. And yeah, those are the things for this firewalls. And coming to the warehouse, it is pretty straightforward. The pre-engineered metal builders had given the loads, and there were not too many complications here. It is we had provided shallow foundations for the loads given. Only the thing is for the truck loading shed, we have the combined footings. And here there were some combined footings to uh, because on the within the warehouse and the truck loading shed, they have like some overhead material systems going on, so that the intermediate columns were required. And it was but shallow foundations were sufficient. And all around the building, like every building, we have a thickened edge running around to avoid the frost depth. So this is a common detail that was utilized all around the building. There is a thickened slab, so that we so as to avoid that 12 inches frost depth from the uh, floor, the ground level. And there were some generic details provided for slab control joints. The slab control joints were defined based on the 1 second. Yeah, here is the control. The slab control joints were defined based on the calculations done for the fiber reinforced concrete and yeah, some details for corner reentrant, discontinuous joint, key, standard key along with the water stops. So, yeah, those are these. This is the electrical room within the upper building and the foundation for that wall of that electrical room and the roof framing plan here. Completely steel beams and the 4-inch concrete deck. Those are the things. Any questions? Is there any questions for me or? If there were no questions, that's it from my end.
I think there were no questions, Mr. Fani. Participants, any questions? Okay. Okay. Thank you, Mr. Fani.
Okay, thank you very much.
So participant, a small announcement. So that tomorrow's lecture will start. Tomorrow there will be 3 lectures. Last day of the Atal FTP. So the session starts at 2 p.m. afternoon. And
Sir, something quiz exam is there now, sir. At what time, sir?
so the exam is around 8 o'clock assessments. So the exam should be written on the Atal FDP thing. So you can directly log in into the Atal FDP and you can see assessments there. Assessments portal will be available there. And there, if you click on that, the exam starts at 8 p.m. tomorrow. So the exam is for 30 questions and 30 marks each. So in the cutoff mark is around, I think it is 70%. So I need to check it once. So I'll confirm you the details of the cutoff by tomorrow.
If there is a exam link is available tomorrow, will you send me so we can easily collect?
Actually, that link is directly uploaded in the Atal website only.
Okay, sir. Which one that we have?
You
sir?
can. So you have to write it directly in the Atal website.
Okay, sir. Right, sir.
And after that, for getting certificate, you need to submit a feedback form that I will intimate the participants by Sunday. So after completing that exam and after submitting the feedback from the Atal FDP, you will be directly getting the certificate.
Tomorrow only the certificate will get.
No. Mostly by Monday.
By Monday it will
Tomorrow
get.
only exam. Feedback session, I will be, after completion of this all sessions, we will be submitting to the Atal that our sessions has been completed, and they will be creating a feedback link.
Okay, sir. Right, sir.
So I'll be just informing you through the WhatsApp group that if the feedback form is available, I'll be informing you. You can directly fill the feedback form from the Atal website, and from there you can get the certificate directly from the website only.
Okay, sir.
So
Right,
these
sir. Right.
things I'll be informing you by tomorrow.
Okay, sir.
Okay. Feedback link for is shared in the WhatsApp group and also in the chat box. So thank you all.
Thank you, sir.